Good morning, everybody. My name is Paul Smith. I'm with GE's Critical Power Division. At least that's the name over the door at the moment. Our history has been fairly long and I won't say checkered because it's not really been checkered. In the telecom power arena, we started off life as part of the AT&T Power Division, building switching power supplies for central offices. You may have seen us build as Tyco Electronics at one time. We certainly did that. We were Lineage Power for a fair amount of time as well. And throughout this, we're now part of GE. Throughout this, we've been dealing primarily with 48-volt DC systems for telecom switches. So the central office where the mantra has always been, you pick up the phone and there's always a dial tone. The lights may be out, but there will be a dial tone. We like to think that's our fault. We're going to talk this morning about an application for OCP in the data center for OCP rack powering. And our particular slant on this is a proposal that we've put together for a contribution, and it's going to look at a true three-phase, and the input range will be from 380 to 480 volts, plus or minus a bit, and give you a 48-volt DC output. It will give you a full 24 kilowatts. That's 4 modules, 4 6-kilowatt modules. So depending on whether you want to provision with N+1 redundancy, you can call it 24 or you can call it 18 kilowatts in total. The shelf is 2 open rack units high. It'll be fed with a 50 amp AC cord whip, which will plug into some sort of standard, either some sort of standard receptacle, or it can be blunt cut and you can connect it to a terminal block. One of the unique aspects of this is using busbar clips for the 48-volt output. Most of the current shelves use busbars which bolt to the rear busbar. We feel that the clip technology is now sufficiently advanced that that gives you a lot more flexibility. You can put the power module anywhere in the rack. You're not limited to where the busbar bolting apparatus is provided. In terms of benefits, simple AC wiring, 480 volts, 3-phase is pretty ubiquitous. It's around all over the place. There are UPSs, should you want to do backup that way, that provide 480 volt 3-phase. But really the 480 volt 3-phase is a good way of getting power from the service entrance panel to the remote location where you need to use it with minimum losses. You'll be seeing some other approaches using 400 volts or 380 volts DC to reduce losses in that transmission path. In practice, three-phase high voltage AC like this has the same benefits because you don't incur the same losses as you would with lower voltages. Either the losses are lower or you're paying more for copper cables with the lower voltages. That AC infrastructure is already there in a lot of buildings. It doesn't have to be added as something special, so that's another advantage. It also gives you automatic phase balance. If you're powering systems off of individual phases, single-phase power supplies, at some point you have to worry about whether you're using power from all 3 phases that come into the building equally. Because if you don't, you'll overpower one of those phases, especially if you're using a UPS, but it matters no matter what you're using. With a 3-phase system, it draws power off of all 3 phases equally, and you don't have to worry about phase balancing. It can go anywhere in the rack, as I mentioned, because of the clip technology. And we're also providing a controller which will talk to anything else in the building in terms of building control or power control through an Ethernet protocol. We're actually working with the protocol group as well to look at other options for communications. This is an inspired submission put through the Web Foundation contribution license. And this is what it looks like. You can see here we've got 4 plug-in modules. There are screw retainers to keep them in place, but the shelf itself can be installed with minimal effort without the rectifiers in. If you put the rectifiers in first, it's pretty heavy, but the shelf itself is pretty easy to install, and the fact that it clips in rather than bolts in helps that as well, of course. From the front, you see on the left there's the controller in the top left slot. Below that is the communications port. There are actually two ports there. One is for Ethernet communications, and the second is what we call a multi-shelf interconnect. This is so that should you have need for more than 24 kilowatts in a rack, you can put in a second rack, and the 2 racks will talk to each other and share power correctly between all of the rectifiers in 2 racks. In theory, you can add more, but we don't anticipate people wanting more than 2 racks at this point. On the back view, not a very good photograph here. For some reason, I forgot to take good pictures of the back of the unit, but there's not much on the back. There's a strain-relieved AC input cable at the bottom there. It's inset a little bit into the back of the module so that the bend radius doesn't have to be excessive to bring it up to the top of the rack. And then there are those 2 connector clips, one above the other, that plug onto to the bus bar. In terms of a block diagram, you've got the Ethernet connector on one side, the system controller, which is just a microprocessor controller that talks to the rectifiers, as well as talking to the Ethernet external. 4 rectifiers plug in. They're obviously field replaceable units. They're hot swappable. The controller knows how many modules there are there, so that you can interrogate the controller for capacity, as well as health. And then on the back side, 3 phases, 4 wires, 3 individual phase wires, and non-current carrying ground coming in there in that whipcord. In terms of the OCP tenets, we've tried to address each of these: efficiency, scale, openness, and impact. From the standpoint of efficiency, the AC distribution efficiency comes into play here, and we estimate that there's probably a 1 to 2% improvement over a single-phase distribution system in total in the AC distribution, which offsets the fact that a 3-phase rectifier is inherently just a little bit less efficient than a single-phase rectifier. The higher input voltage helps, but the 3-phase conversion doesn't work in your favor. But we still achieve 97-point-something% efficiency in the actual rectifier itself. And then the DC distribution efficiency, obviously 48 volt. If you compare it with 12 volt, the losses are lower, and the ease of providing battery backup is improved as well. We did some studies a while back on where that AC distribution loss occurs, and compared for different rectifier styles in terms of the 3-phase 480 volt, the 3-phase 208 volt, and a single-phase 208 volts, and you can see that there's a considerable improvement in distribution efficiency. The losses are significantly lower in a 3-phase distribution system. Compatibility, it's obviously designed around the Open Compute physical dimensions. It fits in the short 48 volt rack with the associated UL listings and dimensional compatibilities. It's designed currently to fit with the width and the fastenings of the Open Rack 2.0. In terms of compatibility, looking in from the front, we've got the two diagrams that we saw before. Obviously, it's compatible with the 48 volt requirements of the system, as well as the 480 volts AC input. The DC output parameters are consistent with Open Rack Standard V2, as are thermal design requirements. When you get high efficiency rectifiers, the thermal output of a system like this is obviously the higher the efficiency, the lower the thermal output. So it's not too difficult to meet that. And then the I/O system Ethernet, consistent with the hardware management project, which we're getting involved with to make sure that we keep up with changes that may be going on there. In terms of scale, it can be mounted anywhere in the rack. You can add rectifiers. You don't have to put in all four rectifiers if you don't need the full 24 kilowatts. Don't have to pay for that up front. If you subsequently find you need more, you just plug in more rectifiers. And as I say, they're plug and play. If you have a failed rectifier, it will get reported. You can unplug the failed one, identified by the lights. Typically in the telecom world, red is a failure and green is good, and that's typically the way our rectifiers work. Although we're obviously looking at the Facebook specification using blue indicators for colorblind recognition. But LED indicators are a standard part of those rectifiers. It's not necessary to dedicate a position for power. You can add a second rack if you need to, just that interconnect between the two racks to ensure proper current sharing between all the rectifiers. Openness, we've submitted this as a contribution. It's the spec we've submitted for 380 to 480 volt three-phase. We will have the 3D CAD model for the external envelope. We're not planning to open up the electronics parts of the rectifiers. That's a little bit difficult to do in the current environment. In the future, we're looking for a compliant product in the future. In terms of communications with the rest of the systems, SNMP is standard and built into our system for communications, as well as some of these other protocols. Mark Johnson is here. He can talk a little bit about that if you have questions on the protocols that we're going to look at. But basically, we're going to allow access to system data, system control, be able to set the voltage, and we're looking very closely at how the intercommunications between this module and a battery module will play. Obviously, that's a key part of the functionality. We're also looking at probably a contribution on a battery module that we've got developed for another application. Individual rectifier data, any alarms that are generated by the system, over voltage, under voltage, excess current, all those sort of general alarms. Rectifier failure, we have numerous ways of detecting rectifier failures. In terms of the system data that's available through the interface, the usual voltage, current, temperature, part numbers, all that sort of thing will be available through that interface. System control, restart, emergency power off, uninstall missing equipment. If you take something out, it gets taken. It doesn't taken out of the inventory in the controller unless you say, yes, I want it taken out of the inventory. Product codes and rectifier, from the rectifier data, individual AC voltages, DC voltages for each individual rectifier, software revisions, that sort of thing. Alarms, there's kind of no end to the number of alarms you can generate if you want them. Most people just want good or bad, so that's the basics. But it can be anywhere from there to every single thing that you see listed there. In terms of impact, the installation in brownfield applications is pretty straightforward. It fits within the larger community, and it will effectively extend the 48-volt user base in the market, and it certainly is a simplification to some of the powering schemes that exist. In terms of impact, orderable parts, we've set up a number of parts here, one for the rectifier shelf itself. The controller and the individual rectifiers are all orderable items and can be available for use. And that's an overview of the shelf. We're happy to look at questions. My colleague Ed is over here to support me, and as I mentioned, Mark is here to talk about communications if that's an issue, because that's not my area of expertise. Any questions?
Good morning. Thank you for the presentation.
Morning.
Just a couple quick questions. Is in your technology, is this silicon based, or are you using wide bandgap technology within the power supply?
I don't know, Ed. It's silicon. Yeah, silicon or silicon carbide, I think, is used in some of the devices, but it's silicon based. Yeah.
And how important in the future is it for you guys to increase your efficiency over the 97?
Well, we're always striving to improve efficiency. Once you get above 97, there's a certain amount of diminishing returns. When you look at the energy that you're trying to save, it's fractional in terms of the heat generated. Yes, we're still striving for better, but it always comes at a cost. And I know this industry is very cost sensitive, so there'll be a balance between energy savings and cost. When it really comes down to saving energy within the total building, the rectifier is not the culprit.
And just one last question: are these 1200 volt devices in there?
The topology is set up to use standard off-the-shelf 600 volt FETs.
Okay.
It is a platform product. We sell it in derivatives all over the place. And so we have standard programs where we fold in efficiency improvement over time. Okay. And so it's not a one and done, this is it, it'll never get better. It's a part of our product line, and we'll continue to make it better over time.
Okay, great. The reason why I ask, I'm from Transform, and we do gallium nitride power switches. Thanks.
Hi. I have a question more related to the controller. I noticed you mentioned about the software revisions in the in the data that you can get from the Ethernet port.
Yep.
So I'm assuming the firmware is updatable on the field.
Yes.
Does that require any downtime from the rectifier itself?
No, absolutely not. The rectifiers are set up so that they will work. You can unplug the controller is a field replaceable unit as well, and you can unplug it, and the shelf will continue to produce power exactly the same as it always has. The only detriment will be that it may not share power between the individual modules quite as well. Current sharing is degraded very slightly, not enough to affect operation though. Each of the modules continues to work at its most recent set point. If it loses communications with the controller, it continues to operate at that last set point. So no, it's not a problem with operation.
Okay,
while
excellent.
you do upgrades or replace the controller or whatever.
The one last question regarding the firmware update itself. Do you guys use the Cerberus to authenticate the new firmware when it comes in, or is that something that's not yet defined there?
We don't use that, no. We typically have done that through the controller offline. We don't do it remotely, although it can be done remotely. Do we have any other
Thank you.
issues on that, Mark?
No, it's the first time we've heard about it. So
Right. We have to look at Cerberus to see what's, yeah.
So I had two questions. My first question was when you talked about pairing like two racks together and connecting them current-wise, if you wanted to have like instead of a 48 kilowatt rack, like a 36 kilowatt rack, how would you recommend setting up the rectifiers in that case? Would it be like 3 and 3, 4 and 2?
It really doesn't matter because they'll all be under the control of the primary shelf. You wouldn't have a controller in the secondary shelf, so they'd all be acting just like the rectifiers in the primary shelf. The only reason for splitting them might be power balance within the bus bar in the back of the rack. So it may be better to put three, try and keep them equal. But again, it depends where you put it in the rack. If you want one at the top, one at the bottom, then you'd probably want to have them split fairly evenly if you're not fully populating them. Yeah.
And then my second question was on your fault alerts, one of the ones I noticed there was incompatible rectifier type. And so I wondered, this whole presentation was about a 6 kilowatt rectifier. Do you have like a form fit compatible other size rectifier like 3 kilowatts or 2 kilowatts?
In this form factor, no. We have others in other applications. We have some 24 and 48 volt rectifiers which are physically the same form factor. And if you were plugging one of those into the others, that's exactly the alarm that you would see. There are no others which would physically connect into this module, into this shelf at the current time, although I certainly wouldn't rule that out because we, as market requires, we're likely to develop other products. Yeah.
Thank you.
Same way that 48 volts has come along to reduce the current seen in 12 volt systems. If I had to make a prediction, then maybe at some point we'll look at 125 volt systems to supersede 48 volt systems to reduce the current yet further. But you start running into safety issues there. 48 volts is nice because it's touch safe.
So all those products are currently available for ordering already?
They are set up in our system to order. We have a sample of the shelf populated with rectifiers and controller, but it is numero uno. It's the first one of its type. So if you were to place an order right now, we could accept an order. It would have a fairly long lead time. But we're in the process of demonstrating that physical sample. And nice lead in, that physical sample is actually on booth B2, which is B2 or B1? B1, which is the Rattel booth. And if you'd like to see it, we can show you the physical first unit that we've produced.
Yeah. So maybe we can discuss further on offline, but we are quite interested in expanding your design to other profiles. For example, for us, for Penguin, we use 208, 277, and 230, and we'll also need more than one DC bus bar clips. So
Okay.
yeah.
Happy to talk about it.
If you
Yeah.
guys go on the design, maybe we can discuss further about those customization.
Absolutely. Yep. Any other questions? Okay. Well, thanks very much for your attention. Appreciate it. Enjoy the rest of the show.